So next up is the one population proportion. We need to determine whether the true percentage is as the company claims of 60% or actually lower than that. So is the percentage below claimed value, and then they're saying it's 60%. All right. We have assumptions that we'll take care of in a minute, but we have the rationale behind why this would be a one prob z interval, and it's a very straightforward reason. This time I'm actually going to get into the interval first. One prop z interval. All right. It's technically a one population proportion z interval, but I don't know too many people who want to write that, at least on an assessment that's not the AP exam. All right. So reasons. This is going to blow your mind. There's one proportion. All right. So that's going to justify the one prop in the one prop z interval. And since there isn't any other choices that involve one prop, that's it. So it's basically a one prop z test or z interval because there's one prop, one population proportion. All right. So mind officially blown, I guess. The assumptions, conditions, a little bit more elaborate. The proportion ones are a little bit more elaborate than other situations. All right. So we have a random sample, so we got our SRS. We also have to assess whether or not a binomial distribution applies. So, conditions. Simple random sample, check. Well, let's see, random sample of 300 people. That sounds like a fixed number, right? A fixed number of trials. Fixed probability. Well, prefer or don't prefer, there's going to be a probability associated with that. The claimed value, 60%, could also serve as the fixed probability. Independent events. If one person prefers a brand, that doesn't mean other people can't. And two outcomes, you either prefer or you don't. All right, so the binomial conditions are satisfied. And therefore, normality all right, and so we just need to determine whether NP and N1 minus P are going to be greater than or equal to 5. All right, so N, 300. So honestly, it doesn't look like we have to assume anything here, because if I take 300, 60% of 300, if we assume 0.6 is our probability P, 60% of 300 is going to be way bigger than 5. Right? 40%, which would be 1 minus P, is also going to be way bigger than 5. So we're good to go on all of these. So check, 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 and check. Now on the AP, if you had time, and like this year is going to be a little bit of a different story, but in an ordinary administration of the AP exam, if you have time, it's not a bad idea to get a little bit more specific with the binomial condition, actually list out the 4 conditions and justify why you think each one is satisfied. But it's not always necessary. Just when it is, it really is. All right. And those situations are usually pretty obvious, as in they'll tell you, but it's a good habit to get into. Calculator function. 1 prop z interval. All right, so the formula p hat plus or minus z alpha over 2 times. All right, well, that's the big question. Well, it's either p q over n or p hat q hat over n. All right, so it's basically, do we have enough information to assume that this sample is coming from a population or that specific population? All right. Now, 165, so I'm just going to denote these values on the side here. X was 165. I almost put bar. N is equal to 300. This is a sample from a population of housewives. Seems pretty antiquated. I vaguely remember changing this too. All right, well, that's a typo bonus. Yeah, kids? I might have changed it to kids and maybe never updated the file. But regardless, housewives, it's so antiquated that let's make it kids. All right, so, like Lucky Charms or, tricks. Tricks are for kids, So some kind of, like that's our target audience, kids who are interested in breakfast cereals. All right, anyway, enough of this housewife nonsense. So, yeah, anyway, I got jammed up on that. Can we assume that the individuals that are being assessed would follow necessarily a distribution whose proportion is the same as the company is claiming? All right, so the company's got this 60% idea in its mind. It's the question of whether or not the population follows that percent. All right, I don't know that we could actually make that claim. So if you're ever in doubt, use the P hat, Q hat. And again, Q, I say Q just as a short way of saying it. P hat times 1 minus P hat. Poor quality hat. Still, the hats are not really working out here. There we go, a little bit better. Over N, all under a root. All right, so P hat, Q hat over N. All right, so we're looking at 95% confidence. So confidence level is 95%, which makes alpha equal to 0.05, which makes alpha over 2 equal to 0.025. It's a Z, so inverse norm on our 0.025 is going to be approximately 1.96. Just going by memory. I'm going to double check that because when I get too cute with this stuff, that's where things start falling apart. And there it is. Okay, so we're good there. So I'm going to store that in as A. So P hat 165 over 300. It's actually a pretty clean value, 0.55. It's not approximate, it's exactly. So 0.55 plus or minus about 1.96 times the square root of 0.55 times 0.45 over 300. All right. So 0.55, I'm going to go with the minus version first, times the square root, fraction tool, got about 0.494 on the low side, less than or equal to P, less than or equal. You may have noticed in these videos I've been using less than or equal to, and in some cases I use less than. It's interchangeable. You can go either way. It's just that the likelihood of your population proportion value actually falling on precisely one of those end values is so remote that it's negligible. But also, we don't look at a line, a vertical line, as having any width. So This goes back to normal approximation, like unit 1, unit 2 stuff, where it's negligible to the point where it's infinitesimal, right? So we don't consider there to be any difference between a less than or a less than or equal to symbol when it comes to confidence intervals, right? So 606 is going to be our high bound. All right. So yeah. Well, what's the claim here? The company's saying 60%. 60% falls in that interval, so we're in line with what the company is claiming. Is that a good thing? I don't know. I mean, I would imagine they're not up to nefarious, or they have nefarious goals here. So you can go either way with it. But and the calculator does bear this information out, so we're in good shape. Because remember, the calculator uses the p hat version of the confidence interval formula, not the PQ over N. So you just got to be careful about that, because we've done it in class where you have a situation where you do it one way and then, on paper, and then do it another way in the calculator, and it doesn't quite match up. So just got to be careful with that. So we are 95% confident that the population proportion of, paraphrase big time here, people who prefer the brand is between, or will lie between, 0.494 and 0.606. Measure is consistent, and like I said, I've just been throwing an X in there if it's consistent with the hypothesis, the null hypothesis of an equivalent hypothesis test. HOP would be equal to 0.6. All right, so I'll just do a 0.5 and 0.6. So my interval would be just south of the 0.5 and just north of the 0.6. And so that's my 95%. All right. Now, they didn't ask us this, but if you were to play around with the confidence levels, just like we would in a lot of other situations, and make it, for example, let's say a 90% confidence interval estimate, then it would just fall short of capturing that 0.6, in which case you'd reverse your conclusion. But you're sacrificing confidence, which makes it a little less meaningful. Is the true percentage as the company claims or lower? True percentage is as the company says. Or did I say claims? So next up is match pairs. For this one, we have to pop some data in. Now, it's not complicated, but when you're dealing with a match pair situation, and these are aptitude tests, we're looking for a significant difference between, let me just make sure, estimate of the difference in population mean scores. That's a key term, because we're talking about the difference. We have to do some calculator work. That's how we know that we're going to subtract our two data sets. All right, but we're talking about a population mean, two population means. One sample. So it's going to be match pairs. so match pairs t-test, t-interval. All right, so assumptions, conditions, and again, just like the last couple of videos, or 3 videos, whatever it is, each time that there's a, this little entry that talks about assumptions, it should say assumptions and conditions. So this is another typo bonus opportunity. All right, so we want a simple random sample, NERP, normal distribution, NERP, sigma, NERP. All right, so we're striking out big time. So these are actually all going to be assumptions. So I'm not even going to label conditions. I'm just going to write assumptions, simple random sample. Oh, my pen is closing up on me. Simple random sample, normal distribution, sigma unknown. All right. So we have our before and afters. Now that's your key indicator that you're dealing with match pairs, regardless of the title saying match pairs. All right. So you know that that's what's going to happen. But what we're going to do is we're going to input our before. I'm going to jot it here because I don't really think there's a better place to put it. The before values are going to go in L1. The after values are going to go in L2. And here the calculator is going to do literally all the work for us, right, after we put that stuff in there. So we're going to do a t interval, but we're going to use the function, or we're going to set it to data, and we're going to refer to L3. All right, so here I'm just going to have it spit out the actual confidence interval. So it's going to be, and a little slight correction, it's going to be mu sub d, because it's the difference between the 2 population means. All right, so stat edit. I'm going to pop my data in to L1 and L2. All right, so I'm doing a t-test, I'm sorry, t-interval, I keep saying that, on data. List 1 would be L3. Frequency values would be 1, confidence level of 0.95. Calculate. I am looking at negative 12.08 on the low end and 2.0763 on the high end. And just so you have it, the formula would be x bar sub d plus or minus t alpha over 2 times s sub d over the square root of n. All right, so these 2 entries, let me just scroll a little bit. These 2 guys here would be x bar and s for L3. That's not a 3. L3. There we are. All right. Now we do have to answer a question. Has any statistically significant change taken place? All right. We'll get to that in a minute. But for now, our templated conclusion, we are 95% confident, hopefully, that the difference in population mean score will lie between negative 12.08 and 2.0763. All right. If this were a hypothesis test, the null would be that mu1 is equal to mu2. That's the same as mu sub d equal to 0. All right. So if 0 could fall in this interval, then this would be consistent with the null hypothesis. If it could not, then it would be inconsistent. So it is consistent. And again, just like the last few videos, I've just been using an X to say that I'm not going to put an in front of consistent with the null hypothesis of an equivalent hypothesis test. So let me just do like negative 15, negative 10, -5, touchdown, then 5. All right, so meh, another meh, right, meh. And so this would be our 95% confidence interval estimate. And you could see here that the 0 would fall in that interval. And so there it is. Everything is, looks like everything is pretty much back to normal, I think. Not seeing anything out of whack. Yeah, it looks like we got it. And there it is.